Hey everyone, welcome to this video for P8105, a course on data science. This is a standalone video on writing R packages. We'll pretty quickly get a basic R package written, and then we'll spend a little bit of time doing some extra stuff to build in functionality for that package. I'm going to start by giving an introduction using slides, and after that I'll demonstrate the material in a screencast. Feel free to skip around to the parts of the video you find most useful. To get the most out of this, code along with me. Everything is available at p8105.com. There are links in the description below. Awesome. Let's get started. All right, so we're going to talk about writing R packages. First thing is when you should write an R package. Back when we were learning about writing functions, the advice was if you use the same code more than twice, you should probably put that into a function. And the reason is that is both clearer in the long run and also more reusable than if you just have code lying around or copy and paste that code more than once. It's really important if you're going to be copy and pasting the same code, just put that into a function because it's going to prevent mistakes and save you time. Same kind of advice exists when you're writing an R package. If you have more than two functions, or if you use those functions in more than two places, you should probably just go ahead and write an R package. And the idea is very similar, that this is mostly going to be about saving you time in the long run. So why should you write this R package, right? And why would you not just like put all of your functions into script or like have them in your R markdown code or something like this? The big reason that you're going to write a function, or sorry, the big reason that you're going to write a package is so that those functions become at least a little bit self-contained. They're off on their own, they do their own thing, but more importantly than that, they have documentation, that there is something that you can write very explicitly that reminds you what a function is supposed to do, what the inputs are, what the outputs are, and things like this. So that it's not just 6 months from now, you open up an R project and there are 8 functions and you have no idea what anything is supposed to do. You've taken some time to say, here are my 8 functions, this is what they do, how they do it, and why they do it, right? That's super important just in terms of collaborating with yourself. It also makes it possible to share that code with other people, whether or not that's sharing code with other people in like a team that you're working with or putting online so that whoever can use this. That's really important. And then there are a variety of other things that you can do in the context of R packages that are helpful, that are a little bit more advanced than maybe what we're going to be talking about in this video, but that are nonetheless helpful. You can like make checks to make sure that the code works the way that is supposed to, that it sort of doesn't break in any way that's unexpected. You can have longer form documentation. You can make sure that everything is really super self-contained in the sense of having all of the dependencies all sort of sorted out and things like this. That's more complicated than what we're going to be talking about today for the most part, but packages allow you to sort of really create a single data product and an object, a data science product, something that you can share with other people and they can use, and that's really fantastic. So this blog post is from a few years ago, and I encourage you to take a little bit of time to read it if you're still like not sure that writing packages is an important thing to do. The tools that Hillary Parker was talking about in this package are now a little bit dated. There's been some new developments from RStudio and the Tidyverse people about how to actually implement an R package, but the thought process is exactly right? That it's sort of it's all about saving yourself time. That writing an R package might seem like something that is going to be really daunting or really challenging or take a huge amount of time to really get the hang of, and it really doesn't. It's none of those things. It actually can be, once you sort of get used to the framework, it can be pretty straightforward, and spending that time on writing an R package really does save you a lot of time in the long run. And then you can, spend your time doing productive things like watching cat videos on the internet. Hillary has a podcast that's worth checking out, the Not So Standard Deviations, and I think is one of the founding members of R Cat Ladies. So there's like a big cat theme going on in R and data science. So that's pretty fantastic. All right, so it's great, you should write R packages, and I hope you're convinced by that in like these first few minutes. So now I'm going to talk about what an R package is. Basically, it is a collection of related functions. They're all sort of doing things that are related to each other. And then there is helpful documentation for those functions and ideally for the package itself describing like what it's supposed to be doing. And all of this is sort of written in a way that is supposed to stand alone, meaning that this package should work all by itself without having to go over here and do this other thing. And don't forget about that other function. And do you need to load this thing? All of that hopefully is taken care of by the package itself. That once you have that package, you can do all the things that you were supposed to do with that package and sort of move on with your day. You can include in packages more complicated things. You can have data sets as part of your package. You can have long form documentation called vignettes. You can have code that isn't in R. You can implement something in C++ if you really want to. I've mentioned tests to make sure that code actually works the way that you think it's supposed to. You can do sort of all of this stuff, but you don't have to. Okay. And so a very bare bones package will include things that look like this, right? Once you have just barely created a package, you're going to have each of these things. There is a description of the package, which is sort of like an overview and some idea about versions and things like this. There is a folder for manuals or help pages that describe each function or each thing you want something to have, each thing that should have documentation. There's a file called namespace, which is a little bit weird, but the basic idea behind the namespace file is your package might use other packages and you need some way to keep track of what those dependencies are. And then you've got a folder for your R code, and that R code is going to be the stuff that implements the functions that you're interested in, right? So you're going to have an R code folder that's just got the functions that you care about, okay? So how should you write a package? And this is sort of structured on that same blog post that I mentioned a moment ago. You do whatever you're going to do until you end up with like 2 functions. And once you've got 2 functions, you think, all right, time to write an R package. Then you create a package skeleton. Here you're going to use a function or a function called create package in the use this package. You put your code into the R folder, and then you're going to add some documentation using Roxygen, which we'll talk about in just a little bit. And then once you've created that documentation, that's pretty much it, right? You can extend your package, you can add some additional functions if you need to, you can change the documentation, you can update some examples, you can do other things like this, and you just sort of work through this process until you're done. And then either you have that package for yourself sitting on your own computer and you can do whatever you need to with it, or you can put it online, you can add a readme so that other people can access this as well, and you can put it on GitHub so that people can install your package directly from GitHub, and that's all pretty fantastic. Okay. The use this sticker I think is a pretty good one. I like that one. I like all of these actually. Roxygen, okay. But use this in DevTools, A+ on the stickers there. All right, so sort of like with writing functions, a really good idea for writing packages is to start small, right? So to have, as soon as you've got a couple of functions, think like, all right, now's the time. Let me go ahead and put this into a package and make sure that it works the way that it's supposed to, so that when things get more complex, when I need to add functions or I need to make the functions more complicated or I need to add some documentation, that all the infrastructure is in place, and then building in that complexity as you need to is possible, right? So that I think is really important. And in the same way that, like, a lot of this is the same advice as when you're writing functions, having a package structure that is clear is often way better than having a package that is like super smart but almost impossible to figure out what it's supposed to do, right? So clarity is better than cleverness is just sort of a general design principle you should get used to. The other thing that I think a lot of people get backwards is thinking about, like, sort of putting their emphasis on the wrong part of a package, right? So you might think this is the best statistical idea in the world and put it into a package. That's usually the least important part of a package. Speed often is more important, but even more important than that is usability. Can you or somebody else look at the functions and sort of understand what they're supposed to do? Can you see like what the inputs are going to be and what the outputs are going to be? And then even more important than just sort of general usability of the functions is the documentation that goes along with it. You should be prepared, and you should sort of recognize that in the same way that like writing code by itself is not great, you really need words around your code so that people can understand what you're doing, and so that includes you, so that you can understand what you're doing. In an R package, spending time on the documentation, writing what it is you need to do and what something is supposed to be, that's really important so that you or somebody else can use that function, use that package in a way that is transparent and obvious and like easy to go along with. Okay, so that's all we're going to say about writing packages for now. What we're going to do next is jump in and actually write an R package. This is going to be awesome. All right, so we're looking at RStudio. It's a little bit different from often how these video goes in the sense that I don't have an R project set and I'm not looking at an R Markdown file, I'm looking at R scripts. And we're going to be spending a fair bit of time today looking at R scripts rather than R Markdown files. Basically, an R script is everything that you would put into a code chunk. It's direct code that you want to execute. We're not going to worry about like text or knitting or output formats or anything like this. We're focusing on like writing R code directly. And the functions that I have here, the code that I have here is first this sim mean and SD function that gives, that takes a sample size as an argument, a true mean as an argument, and the true standard deviation as an argument. And given that sample size, that mean, and that standard deviation, generates a sample from a normal distribution, puts that into a tibble, and then from that tibble summarizes to get the sample average and the sample standard deviation. This is a function that we've seen before. If you sort of remember back to videos that had to do with writing functions and with simulation, this is the kind of thing that we used. And we used it so that here, if I run this line of code, I can now do sim mean and standard deviation. And I want to be clear here. Now, this is a function that exists in my global environment because I've executed this code. It's a function that I can use. And if I give this a sample size of 30, I can run this line of code and it says it doesn't know what a tibble is. So I'm going to load the tidyverse. And now if I run this line of code, it gives me a sample mean and standard deviation. And I can run this a bunch of times to see what that looks like. And we use this in the context of like a situation like this. Again, if we're running simulations, we might want to, for each of 4 sample sizes, rerun sim mean and standard deviation 1,000 times, and then from that extract the sample means and standard deviations so that we can make plots that look like the following, right? That show what the distribution of the sample mean looks like when the true mean is 2 and the sample size is 30 or 60 or 120 or 240. Right? That's the kind of thing that we have used this function before in the past. And we're not going to worry so much about simulations today. That's not what this is about. I just wanted to remind you, this is a function that we might care about. This is a situation that we might want to put this function into a package so that we can use it quickly and easily somewhere else. And we might have some other simulation functions that we want to use as well. That's really what we're going to be focusing on today, is how to put this function into a package rather than like creating a function as an object in our working environment and using that. So what I'm going to do right here at the outset is use this package to create a package skeleton, and I have to give it a path. And again, since I'm not inside of an R project, I haven't done anything weird like this. I'm going to use an absolute path to create on my desktop a package called, we'll call this example package. And it does a variety of things, including opening a second instance of RStudio. So I can sort of go back over to the first one, and it says, all right, it's creating this, and it's setting an active thing, and it's writing R and creating description and doing some of this other stuff and adding all of this, whatever. It's done a variety of things, and I'm just going to close this out and return to this, which is more like a usual R project infrastructure. I'm here in example package, and it's created a git ignore and a build ignore, which we won't worry too much about. It's created a description and a namespace and an R directory and an R project. And since this is a project for an R package, I have this build panel, which is going to let me install the package and restart R, run some checks, and do a variety of other things. But this is sort of the infrastructure that we're looking for. Okay, so what I'm going to do now is here on my desktop, I've got example package I'm going to put over here, and I've got a few functions. This example script is the thing that was open right at the outset that showed the function and then like ran through how we might use it. And I don't really need that anymore, so I'm going to get rid of it. So what I'm going to do next is take this sim mean and SD R file that just has the function, none of the extra code that we looked at, just has this function, and I'm going to put it into my R folder, right, inside of the package. Now, there are a variety of ways that you might do this. You can write an R function and you can use this and use R and do some other stuff. I find this helpful to like write an R script, put the function in it, and then just put that R file in my R directory. Okay, so here we go. I have now inside of this package, I have a script that contains that sim mean and sd.r file. So I've now added a function to my package, and that's not quite enough to make this like a full usable, user-friendly package. The next thing that I need to do is add some documentation. And this is where things are going to get a little bit strange. The way that I'm going to add documentation is using an infrastructure called Roxygen. And we're not even going to worry so much about what that means or how you might use it. What I'm going to do is, with my cursor on the inside of this function, I'm going to go to Code, Insert Roxygen Skeleton. And the inserting Roxygen skeleton puts a bunch of lines up at the beginning that start with the £sign and like a little quote, and then we've got like the title, and then we've got these things at parameter, at parameter, at parameter, and I have one for n, one for mu, one for sigma, and then this says, what is the thing return? Is this function exported by my package so other people can use it, and do I have any examples? And so let's just sort of put some of this in here. I'm going to call this sim mean and SD. This function produces a sample from a normal distribution and returns the sample mean and sample standard deviation. So this is both the title of this function and some short description of it. And then I'm going to give like a collection of descriptions of the parameters here, the arguments that go into it. So n is the sample size, the true mean, and the true standard deviation. And the return is a tibble with sample, mean, and standard deviation. And it's going to, I'm leaving this thing export to indicate that this function should be exported by my package so that it's something I can use. Then I've got examples. I'm not going to put any examples yet. We're just sort of getting bare bones documentation here. So I'm going to save this. And now there are a couple of things that I can do here. I can either go to more document. I can use a hotkey for this. I will often do something like DevTools document package. And it's going to update the documentation. It says there's a warning here. Examples requires a value. It's a warning. I'm not going to worry so much for now. It says it's writing namespace, writing simmean and sd.rd. So let me first sort of go back and see what is this simmean and sd.rd. Okay, so before creating the documentation, I had namespace, r, description. I had some of this stuff. What I have now is a documentation, a manual folder, and in there it's got simmean and sd.rd for our documentation. If I open this up, it says don't edit this file, don't do anything to this. It's generated by Roxygen 2. Edit the actual documentation in that simmean and sd.r. So what this is, it's like the R documentation language is just sort of like a weird language. And what we have here is a variety of documentation, but it's drawn from the stuff that I wrote over here in simmean and sd. So the name is drawn from that, the title is here, it's got a usage, it's got arguments, n the sample size, mu the true mean, sigma the true standard deviation, the description, sample produces a sample from a normal distribution, etc. The return value is sample, mean, and standard deviation in a tibble. Okay, so again, what I've done is written information about this function right next to this function over here in this sort of weird comment structure. And then when I used DevTools document, it created or updated this simmean and sd.rd file. Okay, so that all is so far pretty great. And what I'm going to do is cross my fingers. I'm going to install and restart. And installing and restart, it does a variety of checks. It says, does any of this work? Maybe so. And I'm going to come over here. I'm going to load the tidyverse, and I'm going to load example package. Let me run both of these. And I'm going to be real clear. I still don't have anything in my environment, but if I do simmean and sd with n equals 30 and I run this, now that function works, right? So previously, I'm trying to like draw attention to this. Previously, if I had wanted to use this function, I would have had to go over in this script, define this function, highlight it, run it, and then have access to that as an object in my global environment. Now I have put this into an R package that I have loaded. I've installed that package and then loaded it, and I don't have to have that function in my environment anymore. R knows that that function exists and I can use it. And even more than that, I've got let me see if I can do this, !simmean and sd will load up a documentation page exactly the same way that any other function might have a documentation page. So now I've got sim mean and SD. This function produces a sample from a normal distribution. The usage, you should use sim mean and SD using in this way. The arguments are the sample size, the true mean value, and you've got a value here. This is awesome. We have made an R package, right? If you stop this video right now, congratulations, you have made an R package. That's like, this is kind of all there is to it, right? Like you get your code, you have a function, and it's a function that we wrote previously. You put that into an R script, add some documentation, make sure that you add that documentation using like DevTools document, or like I said, you can come over here and document this way. And once you've done those things, install and restart, congratulations, you have a package, right? So this example package that I have over here has the description, the manual, the namespace, things like this. It's a real thing. It's a whole package all by itself. Okay. So again, you can stop now if you want to. I'm not going to stop. I'm gonna keep talking about a little bit of other things that are helpful just to sort of know about. So the first thing that I'm going to cover is the package description. So the package description here is called example.package. You can give it a title, what the package does, one line title case. So example package is an example package. Okay. I'm not going to change the version number here. A lot of this stuff is, you can say who wrote this thing. Jeff Goldsmith. I am the author and creator of this package. Jeff, what is my email? jeff.goldsmith@columbia.edu. And I don't have one of those. What the package does, this simulates data and summarizes results. License. So here we can use license MIT or use license this or something like this. The encoding, the lazy data, something like this, I'm not going to worry about. I'm going to save the description, and I am going to use, let's just say the MIT license. So let's use this, use MIT license, and I think name, I'm going to say is Jeff Goldsmith. And it says it's now added a license and probably updated the description. MIT plus file license, right? So I've got an actual license here for me, 2020. Neat, great. License.md, copyright hereby granted, free of charge. Everybody can use it. Neat. Okay. So I've got the description. Now again, the description file is a little bit strange. It has to be structured in almost exactly this way. And one of the things that can be a bit of an issue is like when you start trying to edit the description for a package, you can find yourself like having done something that is wrong, that is like a little bit hard to chase down. But for now, I'm not going to worry about it. I'm going to say that I've done this well enough, and I'm going to install and restart. And I think, can I run now example package? Let me find, no, where can I find? Let me look at sim mean and SD. I can go to the example package index and find the description, and it's got like this full description. Honestly, how often do you use the description? It's relatively rare, but it is important to have, and so you can, create a description. Okay, fantastic. I am not, I've sort of been dancing around this idea of stuff that has to go into an R package, and we've talked about the R code, we've talked about description, and I'm going to click on namespace and just point out that like stuff in the manual file, this is generated by Roxygen 2, and you shouldn't edit this by hand. Right now it's just saying what functions get exported by my package, right? And that's enough for now. We're not going to worry too much about the namespace, at least not yet. All right, so we'll sort of come back to the namespace in a minute. But the first thing that I'm going to do is just say, like I've said, you can extend the functionality here in a variety of ways. So there's another function that I wrote a couple of minutes ago, and let's just sort of open this up. I'm going to copy it into the R folder first, and then I'll open it up. So this function, instead of simulating a mean and standard deviation, similar structure, but what I'm going to get out of this is a tibble where for a given sample size, it generates data from a binomial distribution, zeros and ones, with some set probability. And maybe I'll give this a default probability of 0.5, okay? And then given this, it's going to take that simulated data and summarize it to get an estimate of whatever that probability is. So I have a true probability and an estimated probability. Sort of like in the normal case, I had a true mean and an estimated mean and a true standard deviation and an estimated standard deviation. So what does this function do? If I look at sim Bernoulli mean with a sample size of 30, my sample average, my p hat here is 0.533 or 0.67. I can do like prob is equal to 0.8 and start getting values that are up there. Again, it's a way to simulate data from a particular distribution and get a summary as a result of that. And you could do a whole lot of, you could do an awful lot of simulations based on this if you wanted to. But again, like looking at simulations of how quickly your estimated p hat converges to the truth. That's not something we're worried about for right now. We're writing packages. So what I'm going to do with this code, same process I did before, insert Roxygen skeleton. I'm going to give this the sim burn mean as the title, simulate data from a Bernoulli with some probability of success and return the estimated probability. And here is the sample size. Probability is true probability of success. Return is a tibble with the estimated probability of success. This is going to get exported, and there's some examples that I haven't done yet. So what I'm going to do, again, I've added a function. I've added documentation. I'm going to do DevTools document. It's going to update that documentation. Ooh, did I do something else? Warning conflicts. Simburn mean it masks example package. Oh, that is a bad deal. Simburn mean. As example package. It's strange. I'm gonna ignore that for now. See what happens. Okay, so let me now double check what happens. I have in the environment. Let me remove. Maybe that's sort of what my problem is. Sim burn mean. You know what? I'm doing this in like a dumb way. What I'm gonna do is go to session. I'm gonna restart R. That's gonna clear my environment. Okay, and now. Let me double check if I DevTools document, does this work? Everything looks fine. So now I have neither of the functions that I started out with are in my global environment. And if I run sim burn mean from example package with n equals 30, I can run this function as well, right? And I can check sim burn mean, does this have documentation? Yes, it sure does. Here it is. Simburn mean from example package and probability, sample size, prob, true probability of success. Everything is great. We are just zooming along, dealing with things. All right. So what I'm going to do next, this is where things do start to get a little bit strange. So I'm going to, again, go to session, restart R. And what restarting R does is just like, imagine I had just opened this up from scratch. Okay. And now is when we're going to start getting it's a little bit weird because the following is going to cause me some problems. So I used to load the tidyverse library, and now if I run example package but have not loaded tidyverse and I run sim mean standard deviation, it says there's an example, there's a problem. Okay, all right, well, so the reason that there's a problem is because it can't find this function tibble, right? The way I have gotten around this up to this point is just by loading the tidyverse library, right? If I load the tidyverse library, then like it sort of knows where tibble is. But by itself, example package doesn't load the tidyverse library. You can't sort of load a package from a package exactly. But the because I don't have access to that tidyverse library directly from the example package, when I try to run this function, it starts at the beginning and it gets to Tibble and it says, I don't know what Tibble is. What are you talking about? Like, right? So what we have to do now is sort of spend just a couple of minutes working on dependencies. And again, this is the kind of thing that is important if you want your package to really be completely standalone, but is maybe not the most important thing to deal with if you're just like writing a quick package for yourself. So here, what we're going to be talking about is dependencies. And so there are a couple of ways that we can include the functions that we need from the packages that they come from in our own package, so that it is in fact a standalone thing. And we're not really going to get into this into a huge amount of detail, but I want to be clear about how this might work. So there are a few things that we're actually using here that are not standard R functions, right? So we're using Tibble, which comes actually from the Tibble package. rnorm is a built-in R function, you don't have to worry about it. But then we're also using summarize, which comes from dplyr. Mean is built in, standard deviation is built in, and we're also using this thing, the pipe operator, which we use an awful lot, but is also not like built into R. So we need some way to say in this function, where does Tibble come from? Where does the pipe come from? Where does summarize come from? And there are a couple of ways that we can do this. One way that we can do this, and I'll sort of demonstrate this for Tibble, you can use Tibble : Tibble, which will say, as long as you have the Tibble function installed somewhere, it's going to know exactly, or sorry, the Tibble package installed somewhere. This is going to be very clear where this is coming from. We can also edit the Roxygen documentation in a couple of different ways. So I can add import, and I'm going to import from, in a particular case, the Magritter package, and this package is the thing that includes the pipe operator. And so I'm having to be a little bit careful here to say import from this package this function. And it's a little bit weird because we often don't think of this as a function exactly, but it kind of is, and it exists inside of this package, right? And then the last thing that I'm going to do, I am going to import, and I'm going to just say let's import all of dplyr, right? Now there are a couple of things that I could have done differently. I could import from dplyr summarize. I could use dplyr : summarize. I can do a variety of different things, right? But I'm sort of trying to demonstrate that there are several different ways that you can add functions, add functions from other packages to your package. One of them is this, and in general, if you can use package : function, that's a good way to do it. You can import specific functions from specific packages, or you can import entire packages. So here, even though I'm only using summarize, if I did other things in this function, if I wanted to group by, or if I wanted to do other dplyr kinds of things, I could do all of those things, and R would sort of know that that exists. Okay, so I'm gonna save this, and I'm gonna copy these two into my other function. Let me make sure I get the Roxygen structure correct, and I'm going to do Tibble : here. Okay, so let me do DevTools document. Document. Okay, it is updating the namespace. Examples requires a value. I'm not going to worry so much about that. Let me go back over here to Files and take a look. So now I have this function, this package exports both of these and imports this package and imports from Magritter this thing. And I'm going to do one other thing. In the description, right now it's not listing any of the packages that I use, and as a general rule, to the extent that you care about your description, it's useful to be clear that this happens. So I think it's use this, use package. Yeah, I'm going to say use this, use package, dplyr, and Magritter, and Tibble, right? And what this is doing in the description is saying that this package imports from dplyr, Magritter, and Tibble, so that, again, if somebody else went to install this and they didn't have those packages installed, it would sort of show up in the description, and they would get a sense that this is something that needs to happen. And that's maybe a little bit less important. All right, but, so let's do this whole thing. Let's install and restart. Close that file. Oh, there is no package dplyr. Oh, I've messed something up badly now. So let's go into the description. Dplyr, that's right. Let's go mean and SD. Here it is. Import dplyr. Okay. And here import dplyr. Let me try to document again. Updating. Let's try. Okay, so fingers crossed. You gotta watch out for these typos. Install and restart. That worked. Check environment. Okay. Now I'm still not loading the tidyverse, and I'm really crossing my fingers. Okay. Great. Now this worked, right? So again, like I feel like this is sort of a strange thing. I have not loaded the tidyverse, and previously, when in the last version of example package, if I just loaded that package and tried to run this, it gave me that error that said, no, sorry, I don't know what Tibble is, right? Now I've been a little bit more explicit in this function. Tibble comes from the Tibble package. I'm telling you where to look for the Tibble thing, and I also sort of took a couple of extra steps and said, you need to find this function and you need to find this function as well. I've done all of that, and now I can just run these functions directly, right? So the goal here, or the purpose of this chunk, has been to be very explicit about what other packages my package depends on. And the reason is that somebody else might want to just load this package and go straight to running functions from this package. And unless I'm clear about the dependencies, that's going to cause an issue. Unless I say, no, you really, you have to go and find this in Tibble, you have to find this in Magritter, you have to find this in dplyr. Unless you're explicit about that, this causes a problem. So, all right, so now this is great. I have a package that is like really standalone, does two things, got two functions. Those functions have documentation. I can look through those. I guess I'll sort of just finish out this documentation a little bit. Let me say an example here is sim burn mean of size 30, and this one is sim mean SD. Let's make that of size 30. I'll save both of those. DevTools, document, writing namespace, writing simburn mean SD. And let me just sort of double check. Install and restart. This is sort of the process that I use pretty often. Change a thing, update the documentation. If you haven't changed the documentation, you don't have to. Install and restart. And now let's double check. Simburn mean has an example, simburn mean of size 30, and if I run this example, then it gives me some example output. Okay, so this is sort of how these things go. All right, now I've been doing this kind of a lot, where I've actually done quite a bit of stuff. I've added functions, I've updated documentation, I've done a lot of that stuff, and I've been doing that without worrying about Git and GitHub, and that's what we're going to worry about now. And I guess I could have done these two steps a lot earlier in this video, and like actually, and maybe that would have been for the best, right? Maybe what would have been helpful as I'm building this package is to make sure that it is a Git repository and that I am committing and keeping track of the things that I'm doing. I focused more on how to create a package and less on like that usual commit process. And I want to encourage you, if you're like writing your own package, I would like create the package skeleton and then do Git and GitHub immediately after that. But I sort of skipped that part for this video, and we're returning to it now. So what I'm going to do is use this, and what I want to do inside of this, so far there's not any Git infrastructure, but I'm going to use Git. I need to use Git, and it's going to say there are 9 uncommitted files. Do I want to commit all of these? And I'm going to say yes. And then it's going to say adding files, commit with message, initial commit, restart of RStudio is entire. Do I want to restart now? I do agree to that. It's going to do all of this. So now I've still got my build tab, I've still got install and restart, but now I've got this Git business, and I can check that the first commit did an awful lot of stuff, right? It added all of these functions, it added all of these files. And if I were to go in now and like edit one of these, where I might say, let's have simburn mean with 30, and then let's do simburn mean n equals 30 and prob equals 0.75. Now I'm going to do DevTools document. And that's changed both of these two files. Let's install and restart just to make sure. Okay. Add both of these. Now I can do that usual sort of commit stuff. And again, if I were building a package myself, I probably would have done this a lot earlier, but for the purposes of sort of explaining how to build packages, this is something that I skipped, at least initially. So this is like adding an example to sim burn mean. Okay. All right, so what I've got now is sitting here in front of me, I've got a Git repository that is on my machine, but it's not connected to GitHub yet. Again, like I guess I want to review the workflow that I've used for this video because it differs a lot from what we've seen in the past. What we've seen in the past is create a GitHub repository on GitHub, copy that as a project locally, and then sort of the Git and GitHub is already sort of established from the outset. But here, for this video, what I started out doing was creating the package skeleton, and now I've made it a Git repository also using use Git, but I haven't connected it to GitHub yet, and that's sort of what I need to do now. And again, I want to be clear, if I were writing a package myself from scratch, almost certainly I would use this create package and then immediately use Git, so that same sort of Git infrastructure is there. I didn't for this video because mostly what I wanted to worry about was the R package stuff, and to be clear that you can just write an R package on your computer if you want to. But I do think it's important both to have that as a Git repository where you can make multiple commits, and you also want to eventually probably put this on GitHub so that other people can access it as well. So that's what we're going to do now, and I'm sticking with use this, and I'm going to use GitHub, and let's just see what this does for us. So it's going to say which Git protocol do you want to use. I'm not going to use SSH. It presumes that you have SSH keys set up, or if you don't have those or you don't know if you do, stick with HTTPS. That's what I'm going with. Do I really want to do this? It's given me an example package is the name, and description example package is an example package. You can do some other stuff in here also. Does this work? Absolutely it does. Create a GitHub repository, pushing master and setting remote tracking branch. Opening up Safari, and here it is. I have got now the R package at example package. I've got my 2 commits. It's keeping track of all the commits that I have. It's got the R, it's got the manual files, it's got all of the stuff that I would need to have. Now, this is pretty great. I guess I don't yet have a README. We'll see that, I think, in maybe, yeah, we'll see that in just a second. But now what's great about this is that I do in fact have an R package that exists both on my computer and as a Git repository and on GitHub. And so again, like the workflow has been a little bit different, but hopefully it still is working for us. Okay, and so now what's cool about this is if I wanted to, I don't need to, but if I wanted to, I could do DevTools, install GitHub from Jeff Goldsmith / example repo, example package. And it's going to do the usual sort of install from GitHub that we've done in a couple of other cases. So now, again, if you haven't been following along exactly like this, you could go and install the same package yourself using this exact same code, and it's gonna work for you. It's gonna be all right. Okay, so the next thing that I'm gonna do, just because it bothers me not to have a README, I'm gonna do use this, use README. I'm gonna make this RMD. And it's going to create here a README RMD output GitHub document. It's got like a note here that I'll talk about in just a second. I don't have any badges. Some packages get badges. I don't have any badges. The goal of example package is to be an example package. All right, you can have a longer description of this. You can install released version from CRAN. No, you definitely can't. But you can install the development version from GitHub. You can install the development version from GitHub using this. Basics example library this. Let's just see sim burn mean of size 30. And then if I wanted to, I could do some other stuff, right? A lot of this is just extra things. So I'll save this. Let's knit. And this creates example package.md. You can open this directly, but it's got like a warning here. This is generated from RMD. Please edit that file. Just edit your RMD, right? Okay, so now I've got some stuff going on here. I'll just commit everything, edit the MD, let's call it the readme. And now I'm sort of back in that usual structure where I can commit and push, and hopefully everything sort of works over here, right? So yeah, now I've got example package, installation, and a quick example for how this thing is supposed to work. And everything is looking just glorious over here. I've got an R package, and it's on the internet, and everybody can use it. And I'm just like really happy about this. So that is, in short, where we're gonna sort of end things now, right? We've done an awful lot today. We have created an R package, and like we sort of noted at some point early on in this video, we had created an R package that was sufficient. If I was just going to be using this for myself, that's, I guess, in some ways sufficient. But what we've done beyond that is edited documentation and made sure that it's sort of standalone in the declaration of dependencies, and we've edited the description to have like a license, and we've added a readme, and we've also put it on GitHub so that anybody else can install this package as well. And so that's actually an awful lot of stuff to do, but it's hopefully you're following along. Hopefully this ends up being something that is useful for you, because again, as I noted in the collection of slides at the beginning of this, writing R packages really is about saving yourself time, so that 6 months from now, if I need to revisit this project, I can open it up and I can say like, well, what does sim_burn mean supposed to be? And instead of having to worry, in this case, it's a pretty simple function, but in more complex functions, if I didn't know what I was doing, I could check my help files and see what I had told myself in the description about what this is supposed to do and what the arguments are and what it's supposed to return and so on, right? So really, this is, I think, going to be useful over a longer time period. It's going to be helpful for keeping track of the kinds of things that you have written functions to do. And for that reason, I really do think that writing packages is important. I hope you mostly agree with that, and that you're like gonna continue, like stick with it and practice. But in any event, thanks very much for watching this, and that's all I got. Thanks.